Question 10. The diagram shows an isosceles triangle ABC, in which AB is equal to 8 meters, and since BC and CA are equal, they're both 5 meters each. ABDA is the sector of the circle, where A is the center and it has a radius of 8 meters. CBEC is the sector of the circle as well, so CBEC. Right, CBEC. So we go like this. And C is the center and radius 5 meters. So right from here we can mark a few other things, that this and this will be the same since they are in a circle. Like this is a sector, so we can say that CE is equal to 5 meters. And since if we ignore this part, we know that this also comes from a circle. So if this is 8 meters, this is 8 meters as well. So we can say that AD is equal to 8 meters. Now part 1 asks us to find angle BCE, which I have already labeled here. And it tells us that 1.287 radians is the correct answer to 3 decimal places. So for part 1, we need to find angle BCE, which I have labeled here. And we're told that the answer is 1.287 radians, which is correct to 3 decimal places, but we need to prove it to them, and this is for 2 marks. So since we're finding this, we have 8, 5, 5, and A, C, B. If we just make this like this, and we're trying to find this, and we can just use cosine theta is equal to 4/5. Since this length, let's just say this is M as midpoint, is 4, and this is 4 as well. So theta is equal to 37, and we multiply this by 2. It's not this angle, it's this angle. So we can find both of this. We multiply it by 2. We can find this and this. So we can find angle A and angle B, and then which is equal to 74. So 180 minus 74 gives us 106 degrees. So this angle here is 106, but this is still not what we're looking for. This is angle ACB is equal to 106 degrees, but we're finding for angle BCD, which is going to be 180 minus, sorry, this was 74. Sorry, this is 106. And this is 74, so this is 74. But since the question says to find it in radian, what we do is we take it at 74 over 108. So we would get 74 divided divided by, I think it's 180 and not 108. Right, sorry, this is 180. Let's just do that. So 74 over 180, because we're moving it to radian, we're shifting it to the radian mode, and pi is equal to 180 degrees. So we divided by 180, which gives us 0.411, 3 decimal places, pi. This is 1.29154. Here. And to 3 decimal places, it rounds off to 1.292. Which is the same as this answer here. So we've got our answer. We've proved it to them that our answer matches with their answer to 3 decimal places. Now for part 2, we need to find the perimeter of this shaded region. That is like arc plus this is like about 2 meters, and this is for 4 marks. So what we're going to do is that first we identify what all we need to know, right? We need to know arc BD, we need to know arc BE, and we need to know DE. So, and we need to add them up at the end, of course. So we just write it as arc BD, arc BE, and DE, which we know is 2 meters. Since this whole thing is 8, this is 8, this is 5, this is 2. Now to find this, what we're going to do is that for arc BE, we're going to take arc BE first. We take this 5 and multiply it by the radian that we just found, as 1.287, and that gives us 6.435. And for this one, we take this one, that's 8, write this also in meters, and multiply it by 0.6435, which we had found earlier. Just a minute. Yes, we had found this earlier. And this gives us 5.148. And we add all of that. It gives us 13.6 meters. And that is our answer for part 2. So this actually comes from 37 over 360, so this angle is 37 and 8 meters. And since the formula for circumference is 2 pi r, so we take this angle, multiply it by 2 pi, and this is our radius, that's 8, which gives us 1.64 pi, and we get our answer here, which is how you get this. This one we already found it before over here. And then we add it up.